Hi, so today I'm going to be going over writing a polynomial function of least degree that has a leading coefficient of 1 and the given zeros. Okay, so what we have to recognize is that this is a real zero. Ooh, let me switch to a different color. There we go. This is a real zero, this is a real zero, and this is a complex zero, right? Because we have this square root. So that means that we also have to consider its conjugate would also be a zero. So that would be 3 plus root 5. All right, so when you want to write a polynomial function from the zeros, first you should write all of your zeros as factors. So -6 would have been x plus 6. That would be its factor. 0 would just have been a factor of x. And then we would have had x minus 3 minus root 5 and x minus 3 plus root 5. Those would be my factors. Now, I do want to simplify these guys, and you're going to start to see that there's a pattern to it. It'll always work out that way. And it would work out to be x minus 3 plus root 5 and x minus 3 minus root 5. So almost the opposite. Okay, so here we go. Now, you really have to do these in parts, and one of the suggestions I always make is to do the conjugates together. Do those together. Don't try and distribute x plus 6 through one of them. It just gets really crazy. So do the conjugates together. Now, this is a great place. You certainly could multiply this all out, but this is also a great place to use one of the properties of algebra, the associative property. So we had parentheses here. I'm actually going to move them and put parentheses around the x minus 3. By doing that, I see that I have actually the difference of squares. So if I think of dots, then I can write this as x minus 3 squared minus root 5 times root 5, which is just 5, so minus 5. Becomes much easier. Now, using the pattern for the square of binomial, you can multiply that and get x squared minus 6x plus 9. Being really careful not to distribute that 2 through minus 5, okay? Again, that's the pattern we've talked about in our classes. If you need more, check out Perfect Square Trinomial video. And so I'm going to simplify that, and that's going to give me x squared minus 6x plus 4. All right, now I still have to deal with this over here, which would give me x squared plus 6x. All right, but I want this all simplified, so I still have to multiply these together. I'm going to use the area model just because when these get really long for me, I prefer that. So I'm going to make an area model with a 3 by 2. I'm sorry, that kind of got crooked there. So x squared minus 6x and 4 and x squared and 6x. Okay, so now I'm going to find the area of each of my rectangles that don't look like rectangles. So that would give me x to the 4th. Let me switch colors here. Negative 6x cubed, 4x squared, 6x cubed, negative 36x squared, and then 24x. Okay, so then I'm going to simplify that down a little bit. I'll come down here. So we can see that these are going to simplify to 0, and we're going to get x to the 4th minus 32x squared plus 24x. We wanted to write it as a function, and it said the leading coefficient was 1, so I don't have to worry about anything else. And so there would be our answer to question number 45. All right, hopefully that was a helpful video. For more, I might take a look at my video for number 46. Have a great day.